Okay, physics, drag force. So I want to talk with you a little bit about the drag force. So fundamentally different from friction. And a good way to think about this is think about skydiving. So in skydiving, you jump out of an airplane and you accelerate. You accelerate towards the ground, right? That's the fun of it, I guess. And then at some point, you stop accelerating and you go at terminal velocity. So what's happening there is, right, you're creating drag, and as you go faster, you get more drag. This is in contrast to friction, where if you go faster dragging a box, the frictional force doesn't change. Right? So velocity doesn't factor into frictional force. Drag is different. So the definition of drag is when we're going through a fluid and we create increasing turbulence, which essentially sucks away energy, and that increases the resistive force. So let me just diagram this briefly so we're on the same page. So the way I want to think about this, so early on in skydiving, I'm going to have some force of gravity, we call it mg, pulling you down, and I'm going to have some smaller force of drag pulling you up. So I'll call this the drag force. When you get to terminal velocity, you go at constant velocity. So it's almost 100 miles an hour. Right? So I'm going to go mg. And now my drag force must be greater, right? So gravity hasn't changed, but now I have more drag force that's slowing you down. And that's going to affect it. So some of the things you can guess are going to be important. So one, as velocity goes increasing, that I get my drag forces increases, right? So these are going to be directly related to each other. You can guess the size of something is going to matter. So if I had something really big like a parachute, it's going to have a lower terminal velocity than I have something that's smaller like a human hurtling through air. Right? So my area is going to be important. And also it matters the fluid that you're in, right? So if you're diving into air, that's going to slow you down much more quickly than if you dive into water, right? Both fluids, but there's some characteristics of those fluids. So there's a formula that ties this all together. So let me jump to that. So yeah, so this is the formula. Yeah, so this is the formula here, which says that the drag force, known as capital D, is this equation, right? So this is going to be 1/2 times some drag coefficient, which has to do with the interaction between object and the fluid it's going through, has to do with the density of the fluid, and then has to do with the cross-sectional area, and finally it has to do with the square of velocity. So notice the square of velocity. So this is what makes skydiving possible, because the faster you go, your drag increases at the square of that rate of increase of your velocity. So as you get going faster, you get dramatically more turbulence and a greater drag force that slows you down. So these are the key things that they're going to try to do. So fundamental importance, though, is to recognize that when you're in a fluid, you're going to have a different force acting on you, and that it's proportional to the square of the velocity. So I'll let you do a lab to try to explore this a little bit more. Really not a lot that I'm going to ask you to be able to do with this. It's important to recognize the difference, the distinction between friction and drag, and where those two things apply. And then the formula for drag, if you ever need it, will be provided, but it's important to recognize that it's proportional to the square of the velocity. Anyway, I hope that helps. Talk to you soon. Bye.